Okay, good morning, students. We are today. Let us start the class. Today I'm showing you, or today we are going to see uh, how you can create some indexes uh, using some satellite images, and using those indexes, we can actually extract some relevant information. Okay, so for that we are going to use. So I'm going to use RGI software. So I have opened the software, and then I have some of the images which I have downloaded already and stored it in my local drive. First, I will go to load these images in our catalog here, as you can see. For the exercise today, you just pay attention, and then I will explain uh, what kind of index that we are going to use. Okay, so normally when we talk about some indexes, some of the important indexes which can be used for plot mapping is either NDVI or NDVI or NDWI. So these are some of the indexes. So what is NDVI? What is NDWI? Okay. So let us first focus on what is NDVI. NDVI stands for Normalized Difference Vegetation Index. Okay. So okay, so look at this formula. NDVI, or I can just use the whiteboard. NDVI. So normalized difference vegetation index. So here you see NDVI stands for normalized difference vegetation index. So basically this is an index or indicator. Okay. So with the index, we can actually tell about the strength of vegetation, or you can say vegetation, vegetation, strength or vigor, S-T-R-E-N, S-T-R-E-N-V-E-H, or you can say vigor, V-I-V-O-U-R, vigor. So if you can find out NDVI using some satellite data, we can predict, or we can at least comment on how good the vegetation in this particular area is. For example, in case of a forest land, if you calculate NDVI, then normally the NDVI values will be quite high. And in the area where we don't have a forest, or we are devoid of forest, or we have only water, then our NDVI value will be quite low. So basically, it is the strength of vegetation or the vegetation vigor. So why is it important? So this is important uh, in order to know how good an area is in terms of uh, cultivation, or in terms of the regular vegetation. So if you know that the particular area is devoid of good vegetation, or in the particular area we don't have enough vegetation, then we can take some measures to rectify those areas if it is needed, or if you know that some areas will have high NDVI values, that is an indication that in those areas we are going to have very good cultivation, or especially we are already having a very good cultivation. So normally the NDVI is, as I said, this is an index. INDEX. So if I ask you what is an index normally, can you tell me what is an index, or what an index actually is? Or can you give us another example of an index? What is an index? Yes?
So
Yeah. So normally, can you give us, can you give me another index? Actually, index is a dimensionless number. So that means if you take a ratio, or if you, uh, for example, if you calculate the reciprocal, or if you take a ratio to compare between two numbers, or between two values, then we can probably get our own indexes. For example, uh, NDVI, just take an example of NDVI, it is calculated as NIR minus VR divided by NIR plus VR. So NIR stands for near infrared, or in other words, whatever information actually being captured by our band number 4, then VR is known as visible red. So that means whatever information is being captured by the satellite in band number 3. And then you divide this whole with NIR plus VR. So that means ultimately whatever information means in terms of uh, the amount of energy that is actually normally stored in the satellite in these bands. So if you divide that part of an energy, NIR minus VR, divided by another unit of that energy, then the units ultimately will cancel each other, and then this will ultimately be a unitless number. So this is an example of an index. So ultimately, whatever number that we will get will be an index. It is just a number. It doesn't have a unit. For example, if I ask what is your height, you can tell that 163. So if you do not tell me the unit, this number is meaningless. So if I say 163 centimeters, that is indicative of your height. Or someone, if I ask what is the weight, someone tells me it's 57, then automatically it is assumed that it is probably 57 kilograms. But if this is a number, this doesn't have a unit. Why? Because the units are cancelled already by denominator and the numerator. So NIR minus VR, or visible rate, we will get one value, and then NIR plus VR, we will get another value. But again, why we are taking NIR and VR? In that case, I should explain you in this form. Uh, do you remember this usual spectral signature of a green leaf? Remember? So this is our blue band, this is our green band, this is our red band, and somewhere here we have the near infrared band. Okay? So this one is band number 1, this is band number 2, This is band number 3. And then here we have band number 4. This is a typical example of a line set satellite. Okay? LA, ND, S, A, Q, line set satellite. And then in the y-axis we have the percentage of reflectance. That is FA, BC, E, ANCE. So what happens normally in the blue band in case of a leaf LEAF? Do you remember my slide? In the blue band, we don't have a very higher spectral reflectance. But towards the green, this reflectance goes up. And towards the red, it goes down. So normally our human eyes can only see in this range, that is from 400 to 70 nanometers. But in the near infrared, we saw that it actually is a very high reflectance. But the speed, we do not see with your naked eye. What we see this speed of A, but we do not see the speed of B. Okay, so let us now remember the equation of NDVI. NDVI. NDVI is band number 4, that is near infrared, minus band number 3, that is visible red, divided by band number 4, that is near infrared, plus band number 3. Okay, so when the satellite captures this information, this A or the green band is normally our band number 2. Okay, this B is the blue band, which is stored in band number 1. This information is our band number 3 information. This is the information of the red. And normally, this is stored in band number 4. So, if you find an equation or an index involving these two bands, right, like band number 3 and band number 4 here, then you can find out a number where you can see the range. Range means where are the areas where you have highest number of vegetation, or where are the areas where you have a very good vegetation, and in which areas you have a very low vegetation. If you calculate NDVI properly, this range from -1 to +1. Okay. Now you may question me, or you may question yourself, why we are emphasizing so much on NDVI. Okay. So normally what happens, if your NDVI level is very low, that is an indication that those are the areas where we have devoid of vegetation. That means we do not have vegetation, or we have vegetation that is very bad in terms of the strength, in terms of the vigor. So, for example, which may be these areas? If you have a desert, okay, then you may have a vegetation which is very sparse, or at all we don't have a vegetation there. So in those areas, we will see a very low NDVI, that is towards -1. So if you are taking NDVI from an area where it is mostly covered with cultivation or forest, then we will see an NDVI which is normally good and towards +1. So depending on these values for each pixel, you may be able to say if some farmer is cultivating his land, what is the strength of his cultivation, or what is the quality of his cultivation, how much of the yield he may be expecting once he is going to reap, or once he is going to sow. Okay? other thing, in an area, imagine where it is covered with water, we will not see any NDVI. That means we have an NDVI which will be towards -1, right? Because it is seen that normally over water, we do not see any vegetation. Imagine then what happens during the time of a flood. So when we have a flood, we have many areas which are submerged. It means we have an area which is covered or filled up with water. So if you were taking a photograph from space and then you were trying to calculate the NDVI of the whole scene, and then you have some of the areas which are covered with water. In those areas, you will get a negative value of NDVI towards -1. And then you can extract those areas and you can say that these are mostly or highly probable areas which are inundated by floodwaters. So that would be quite a good information for many people who are at the position of making decisions. For disaster managers, you should be able to find out this kind of information and should be able to take some advanced or efficient decisions. Okay, so this is the kind of example or exercise that we will do today. It may involve tomorrow as well. But let us proceed. Okay, so this is my screen here. I already have downloaded some of the images. So for NDVI calculation, I am not going to load all the images. This is a landscape image. So for that, I need band number 3. This is my band number 3. And I need band number 4. So I simply load these two bands. Okay, so here we go. This is an image. Normally, it is not having a path. So, but if I have an image, I have downloaded it. So I just want to show you a little example. And this is a real probably this is the image of it anyway. So these are some of these areas which we suspect is due to floodwaters which are actually seen from space. Okay. So our dam number 3 information is this one. This is the red dam. Okay? And our dam number 4 information is here. This is our near infrared dam. Okay. So now what we are going to do, we will be calculating the NDVI. Okay? We will be calculating the NDVI for this area. So NDVI is calculated as band number 4 minus band number 3 and band number 4 plus band number 3. And we have an image which is like this. Remember, this is a gridded information or gridded data. We are talking in terms of pixels. So we have digital number values for these pixels, for each of the pixels, and then these values are accordingly stored in different bands. For band number 3 also we have this information of same area is captured by band number 3, and then band number 4. This is my band number 4 image, and this is my band number 3 image. And then we are calculating NDVI for the same pixel using this formula. This equation. Okay, so how we are going to do it in RGNS using this image. For that, we need to activate our special analyst, but this is another part. Since I'm not teaching you VAS software right now, I'm just explaining in general what we should be doing. So depending on different softwares, we have different approaches. Uh, I hope you have already downloaded and installed NDVI software. If you're not, please do it right today. Okay, so we have tools here where we do the raster calculator. This is part of special analysis. Don't worry about this work, okay? This is quite new for you because I'm showing you the general approach. How normally NVIDIA is helpful in extracting clouded information. And wait a moment, I'm putting out the tool. RGIS has more than 10,000 commands and tools. This is really powerful software. So we have a tool here as well. So, at the moment, you will see the tools. So, till now, do you have a question that you want to ask me? Yeah? No? No question? That's good. So, I think I'm going to skip this calculation part today because I don't think we will have time for that. Maybe about 5 to 10 steps. We need at least half an hour for the exercise. So maybe tomorrow. Tomorrow, we come together. We do this exercise. First, finding out NDVI from the satellite image, and then we can extract the flooded area. And then if we get a flood area, we can extract the areas which are inundated by the clouds. From the satellite image, we can take the facial decisions for bigger purpose. Okay?